In this tutorial, we will demonstrate how to connect and configure the RHP Boson, Hdif. This interface allows you to control parameters on the thermal camera wirelessly from a remote control. To get started, align the interface and Boson camera so that the 80-pin, high-rose connector lines up. Press the camera and board into place until you feel them click together. Using the 4 screws provided, insert each through the back of the 4 corners on the Hdif board, and thread into the Boson camera. Be sure not to over-tighten the screws. Using other than the screws provided could damage the camera, interface, or both. With the interface in place, we can now provide power to the unit. There are 2 ways to provide power to the Hdif. Insert the 4-pin JST connector into the side of the DSIF board, and then connect to a power source, or computer. The power light will illuminate within 5 seconds, indicating the unit is on. Use this option when configuring the Hdif with the RHP controller software. Alternately, power can be supplied using a battery with 6 to 26 volts. Use the 4-pin JST connector with a red and black wire, included in the kit. When connecting the video signal via HDMI, use the provided mini HDMI cable and insert it into the HDMI port on the Hdif. Plug the opposite end of the cable to a monitor or recording device. Once power is supplied, the HD video should appear on the monitor. For this next part, we are going to connect the 10-pin connector and use it to interface with a remote receiver. Since we are using a 16-channel S-bus device, we will only need to connect PWM1 to the wiring harness. The pinout chart shown is set to RC standards. Be sure to follow the guide in the Hdif manual for the correct pinout. PWM mode is used for up to 5 channels. S-bus mode is used for up to 16 channels. The features of the Boson are assignable using the GUI software while connected via USB. Next, simply connect the 10-pin wire harness to the interface. Now we will reconnect the HDMI video and USB cables. Once the connections are made on the receiver and Hdif interface, connect power to the unit. Our receiver shows that our power is on. Once we turn on the transmitter, the status light turns green and is ready to use. In the next section, we will show you how to customize the control settings on the Hdif. When first connecting the Hdif to a PC, be sure the computer is connected to the internet. Connect the Hdif using the 4-pin to USB cable. Windows should automatically find the necessary drivers and download them. With the application open, choose File. Connect. A green bar on the bottom of the screen will indicate that the interface is successfully connected. The program will load the current settings and camera information from the interface. Once loaded, all available parameters will be enabled for adjustment, based on your configuration. Click on the RC Control tab. In this section, we will show how to program the Hdif to use with a controller. In case a calibration of the remote and receiver is necessary, click the Calibrate RC button on the screen. Next, move all channels including joysticks, switches, knobs, or buttons on the RC controller from the starting to the maximum position. You should see the channel status change as each channel is adjusted. Once the calibration is complete, press the stop button. There are 3 parts to the RC control interface screen. The left side of the interface is the RC channel status. If a channel is adjusted, the channel number will be highlighted in green. On the right side of the interface is the channel setup. Here you can choose a switch type and select a function. The bottom portion shows all of the available channels on the device connected. Since we are in S-bus mode, all 16 channels will be shown. When PWM mode is selected, only 5 channels will appear in the list. To get started, choose a channel from the channel table in the lower portion of the screen. In this first example, we are choosing channel 1. This is a joystick on the controller. Select a switch type. We have chosen variable 0 down. Once the switch type is selected, choose a function for that switch type. We have selected continuous digital zoom. Functions shown on the list are dependent on the switch type selected. They may not be available for every switch type. Click Save. The channel parameters will reflect the changes in the channel table and save to the RC controller. It's important to remember, changing a channel before saving will reset the settings for the previous channel. In this example, if we moved on to channel 2 before saving, channel 1 will reset to default. Our second example, we will configure a 3-position switch on channel 5. For the max setting we will set it to palette plus. The center setting we will leave at none. The minimum setting is set to palette minus. Now when we move the switch from the center position forward, the palette will change to the next palette on the list. Moving the switch from the center position backward, the palette will change to the previous palette. Channel 12 is a momentary switch on our controller. We are setting it to a 2-position switch type. Our max setting we will leave alone at none. The minimum setting is set to do FFC. After saving, we can now perform a flat field correction on command using this switch. On channel 13, we will use a variable potentiometer with a 0 center bump. The maximum function is set to digital detail enhancement, plus. The center function is set to DDE, default. The minimum function is set to DDE, minus. After we save, the digital detail can be increased and decreased with the knob on the controller. For the last example on channel 14, we will configure another variable potentiometer with a 0 center bump. This time, we will set it to increase or decrease the tail rejection. Now that we have successfully programmed the RC/Hdif, save all channels. Then disconnect the interface by going to File, Disconnect. With our RC/Hdif programmed, we can test our settings outside with the remote control.